Next, the vector multiplication for dot products. Okay. Dot products. So here we have vector A and vector B. So how we, under the operation of the product, we represent this vector A dot vector B is equivalent to the magnitude of A times the magnitude of B with a cosine angle of theta AB. Theta AB is actually the smallest angle between the vectors, so it is here. So from this, before we go to these situations, let's get our calculator, or maybe we already know in our head. Okay, these two cases. Okay, cos 0 and cos 90 degree. What does that mean by 0? Means the vector, in this case, means the vector are both parallel, going to the same direction. So it is 0 degree. How about 90 degree? 90 degree means that vector 1, for example, is orthogonal 90 degree with a vector 2. Okay. So in representation of Cartesians, for example, let's say we have x here, we have y here, then we have z here. Okay. So let's say 0 degree means the vector, they are parallel. Okay. Let's say we have, okay, here they are parallel, going to the same direction with the same unit vector. Okay. And this one is 90 degree, for example, the vector x with the vector of z, unit z, so they are orthogonal, so 90 degree. So okay, now it will help us to answer this equation. Unit vector of x, unit vector of x. What is the answer? It is 1, because they are parallel. How about this one? Unit vector x times unit vector y, they are orthogonal, so this one is 0. So the same goes for this. So dot product is commutative because vector A dot B is just the same as vector B dot vector A. It also obeys distributive law, where the vector A dot the bracket of vector B plus C is actually can be distributed to vector A dot vector B plus vector A dot vector C. The next we go to the cross product. Cross product can be represented like vector A cross vector B with a unit equivalent to a unit vector normal to the plane containing the vector A and B with an angle of sine theta between the two vectors. Here we can see vector A, vector B, and the angle between them. Okay, based on right hand rule, we will get A cross B, we will get a normal towards these both planes, okay, which is the n direction. So this is the cross product. Okay, cross product of A and B is actually a unit vector normal to the plane containing the vector A and the vector B. So vector products for A cross B is not equal to B cross A. It must have in the opposite directions so that it will have the same normal. Okay, for example, A cross B, we will have a vector in this direction, but B cross A, we will have the direction in this opposite direction. Let's say we represent this as C, for example. Okay, so this one is actually minus C because it's in opposite direction. That's why we have negative here to show the opposite direction. And it obeys the distributive law where A cross B plus C is actually the same as A cross B plus A cross C. Thank you.